Hello, I'm Victor Hu.
I'm Jeffrey Cheng. Welcome to the first video in a series of tutorials where we help you get started with Webots and the Erebus competition.
So today we will walk you through how to install Webots and download Erebus. Then we will go over the basic features and controls of Webots.
Note that if you're watching this tutorial for the Rescue Maze competition for Robocup Junior, the world that you see for Erebus is going to be a little different compared to the Robocup Junior world, but the concepts that we go over still apply to both competitions.
Webots is an open-source robotics simulator used for education, research, and industry purposes. We will be using Webots as the platform for Erebus, the rescue simulation competition environment. While we will be installing Webots and Erebus on Windows 10, these tutorials will still generally be applicable for macOS or Linux.
The following two clips are demonstrations of what Webots is capable of. The first clip is a demonstration of the Erebus R competition. This is what your robot should roughly look like when you're working on the competition. If you skip to 5 minutes and 13 seconds, there will be a demonstration of a line tracing robot. If you skip forward to 5 minutes and 20 seconds, you can resume the tutorial.
To install Webots, first go to cyberbotics.com and download the appropriate list of Webots for your system. In my case, I will be selecting Windows 10, but you can also select macOS or Linux. Make sure that you're downloading Webots R2020A-Revision 1. Next, to download Erebus, go to Erebus's GitHub page at github.com/shadow149/Erebus. Hit download zip and extract the files into a directory of your choosing. Navigate to Erebus Aura, Game, Worlds, and open the world file called Generated World using Webots. The .wpt file extension is recognized by Webots as a worlds file containing all the information about the simulation world, and this can be opened by Webots. After Webots opens the world file, you'll be greeted with multiple windows. The simulation view allows you to interact with the simulation world. Left-clicking and dragging allows you to rotate your viewpoint, while right-clicking and dragging allows you to move the viewpoint around. With the mouse scroll wheel, you can zoom in and out. To select an object, click on it within the simulation view. This will highlight the object and reveal its 3 X, Y, and Z axes. You can zoom in on the object with the scroll wheel, or you can press Alt-5, which will automatically zoom to the object. To rotate an object around a particular axis, click and drag on the rotation symbol attached to the axis you wish to rotate around. You can also hold Shift and right-click to rotate the object around the world's vertical axis. If the object is allowed to be resized, you can resize the object by selecting it and holding Control, and the axis of the object should turn blue. Dragging on one of the axes will resize the object. Note that this robot is configured so that it is not allowed to be resized, and holding Control does nothing to change the axes of the robot. Instead, you can change the scale of a wall by holding Control, and as you'll see, the axis turns blue. To the left, you will see the simulation scene tree. This contains every object and their associated parameters and properties within the simulation. Clicking on an object within the scene tree will also highlight it in the simulation view window. For instance, let's click on Robot 1, which is a Pioneer 3DX. Notice how it is highlighted. So this robot features 8 ultrasonic sensors. You can also expand information about an object and see its child nodes by clicking on the arrow next to its name. Under Extension slot, we can see the additional sensors that we have added to this robot, which include a gyro, a receiver, an emitter, a light sensor, a GPS, and a camera. Next, we are going to practice adding our own custom objects to the simulation environment. While you normally won't have to do this for the actual competition, it's good practice to get familiar with Webots, as well as if you want to create your own custom robots or objects. To add an object to the simulation, right-click in the scene tree and press Add New. The shortcut for this is Ctrl-Shift-A, so this will open up a new window prompting you for the node you want to add. Webots supplies many proto-nodes, which include simulated humans, different types of real-life robots, and an assortment of environmental objects. Webots also has a variety of base nodes, which are primitive nodes that allow you to create your own objects from the ground up. For the sake of example, let's add a Webots proto soccer ball to the simulation. So we can see that the soccer ball has appeared in the simulation view. We can move it around like any other object. And to delete the object, we select it and press the delete key. While we will not be going too in-depth about Webots nodes in this tutorial, you can read the Webots documentation for more information on solids, shapes, appearances, bounding boxes, etc. Okay, so now Jeffrey will talk more about the console, toolbar, and UI window.
So this window right here is your console window. This is where any messages get printed out to. So this includes messages about any commands that Webots may run, any game messages, and any print statements that you print out. If you want to, you can always resize this window by clicking and dragging. If you want to enlarge the text, you can always hit Control and scroll. If you want to clear all the text that's in this window, you can just hit right click and then hit Clear Console, or Control K will do it. So, as Victor said before, Webots is a robotics simulator. What that basically means is I can write some code, link it to robots, such as this one right here, and Webots will run a simulation of that code for me. So let's say I have this robot and I have some code linked to it. We'll show you how to link code a little later on in this video. And I want to run my simulation. All I have to do is hit this play button right over here. And when I do, you can see that the robot starts to move, and this timer starts to count. Now I can also hit the pause button, which pauses the simulation. Additionally, I can fast forward, and I can also reset the simulation. What the reset does is it resets the robot to before I hit this play button. So my robot would come back to here. So now, these buttons over here are for interacting with the simulation itself. These three buttons over here are for working with the world. And Webots will store this entire world into a file, and call it a world file. And the world file stores the state of the world, basically the positions of the walls, the carpet, the robot, and it stores it into a file. Now, I need to save the file because the state of my world changed. This robot moved from over here to over here when I hit play. So then I have to save the changes if I want these changes to stick. Now, one thing you should remember, before saving your world, or editing it for that matter, you should always make sure that this timer is set to 0. If it's not, you can always just hit this reset simulation button and it'll reset the entire simulation, and this counter will be back down to 0. Now, you can feel free to move the carpet or move whatever you want, edit the world, and save it too. Now, let's say you create your own world for your own testing purposes. If you want to open it, all you have to do is hit this file right here. If you don't know how to create your own world, there's a tutorial online on the Webots website, and you can just follow it, and that'll teach you how. This reload world button basically regenerates the world as if I closed out of Webots and reopened it. So now, we're going to talk about this window right over here. We call this the controller window or the Erebus UI, the Erebus user interface. One important thing to note about this window is the creators of this world added this particular controller window to this world, and this world was given to you. What that means is if you generate a world on your own, it's not going to have this controller window. So that means when you use this particular world, you should use the play, pause, and reset simulation button over here, not the ones I talked about before over here. But if you create a world on your own, then since you won't have this window, you can just use these buttons over here. So now, let's say I'm going to load some code into one of these robots. I can tell which robot is which because when I click on it, it lights up in the scene tree. And from here, I can see that this is robot 1, so I want to be looking at this robot 1 over here. So I'm going to load some code into robot 1. And as of right now, Erebus can only accept Python scripts. So all of your code is going to have to be in Python. We're not actually going to talk about the coding in this video, but we will release videos in the future teaching you the basics of coding in Webots. So now, I want to load code into robot 1, so I go into load controller under robot 1. When I click on it, it brings up my files, and I can load a Python script into it. And now you can tell that that a controller has been loaded into this robot because this box has lit up red. Now, from here, I can play my simulation. As you can see, my code runs, prints out hello, and the timer also starts to tick. Now, I can pause my simulation, and the timer pauses, and I can also reset my simulation, and the timer resets accordingly. Now, let's talk about the scoreboard. Let's say I run my simulation, and my robot comes over here. Obviously, I'm faking it, and this is not actual code. And it comes over here, and it sits next to a human, and then it picks it up. Now you can see that my scoreboard will display picked up a human. If you're confused about what's going on right now, you should read the rules. The rules will be in the description of this video, and they will be the rules to this competition, the Erebus competition, that this world is designed for. After you read that, you can come back and resume this video. So now you can see that my scoreboard said I picked up a human. And then now, let's say my robot, obviously I'm dragging along, and this is not actual code, you will have to code it, and it comes back to base, and then it says brought a human to safety. So basically this scoreboard just keeps track of all the stuff that this robot has done. And as you can see, it's on the robot 1 side because the other robot 0 over here has done nothing. So that's the basics of using this controller window over here. Now, there may be some problems when you first set out that you won't be able to load a controller. For example, it won't be green. It'll probably be like gray if it doesn't work. One thing you should try is make sure that you are not paused. So you want the pause option to be on. That means that it's currently running. Even though this timer isn't ticking, you can see that since the pause option is on, that means the simulation itself is not paused. So for the Erebus Aura competition, you should have downloaded this folder called Erebus Aura off of their GitHub page. And inside here, it contains 4 folders: docs, game, player controllers, and world gen. You yourself will probably only be dealing with player controllers and perhaps game. So player controllers is for you to store your main code in. So the main code that will run the robot should go into player controllers. So you can see in here that I have my Python script called code already in here. So this is the code that's going to be running the robots. And if this Python script, your main Python script, needs functions or variables from other Python scripts, then you should place those inside of game, controllers, and then robot 0 controller or robot 1 controller, depending on which robot needs that code. So for example, in robot 0 controller, my main Python code needs functions and or variables from abstraction layer and library, and that's why they're in here. Something to remember is that if you put your main code into this folder, into either robot 0 controller or robot 1 controller, and you load it into Webots, the code inside of there will get wiped. So that's why you should probably store your main code into player controllers, so it won't get wiped there. Remember that this tutorial was meant to give you an overview of the basics of Webots for the Erebus Aura competition. So if you want to learn more or you're still a little bit confused on something, don't worry, there are a few links in the description. One of them will lead you to this GitHub page, which the GitHub page for the Erebus Aura competition gives you a description of the game, all the rules, and all the files that you'll need for this competition. Another one is a link to the Webots website. And on the Webots website, it has a lot more information about what Webots is, what it can do, and it also has a few tutorials. So we highly recommend that you work through those tutorials to become more well-versed in Webots. So next week, we're going to be releasing a video about how to actually code the robot controllers and the basics of that. And if you still have any questions left over, there will be a Q&A session, a live Q&A session that we will host. The date will be announced in the future. And that just about wraps up our first tutorial. So thanks for watching. Have a good week and goodbye.